Today we're diving into how optimization can transform the performance, comfort and overall quality of Class 2 buildings. Yes, we're talking apartments. And joining us is the wonderful Sumit Kenche, our Sustainability Associate who leads all things residential here at Suho. Great to have you with us, Sumit.
Thanks, Ali. I'm happy to be here.
So let's kick off with the basics. What do we actually mean when we say optimization in apartment design?
Optimization is a process of refining an apartment's building design very early on. Now, this is to find a sweet spot between cost, thermal comfort, sustainability, and aesthetics. Instead of just chasing minimum compliance, we actually try to explore how different design decisions impact performance and helps the teams to balance increase in resilience, comfort, and return on investment. It's about designing smarter for better value.
So we're seeing apartment demand rising across Australia. With so many different product types, does building size influence the optimization process at all, or is there an ideal size where performance and cost align best?
Not really. There are many influences on projects' success, such as location, orientation, climate zone, and etc. Our optimization process is tailored to each project individually and it is customized. Now, regardless of size, we analyze the specific design, model the different performance levels, and compare options. Then we recommend strategies and material pathways to achieve desired outcome. This is to happen efficiently and economically.
Interesting, yeah. And how does energy efficiency differ between low-rise and high-rise buildings?
Interesting question. Now, when we compare the low-rise and high-rise building, the energy efficiency challenges are very different in these kind of projects. Low-rise buildings usually have more surface area that is exposed to the environment, which means that they gain and lose heat very easily. So they typically need higher insulation levels and glazing specification. Now, when we compare high-rise buildings, on the other hand, they tend to have more repetitive floor plates and the design layouts, which means that as you go higher, they experience more significantly wind exposure. In warmer climates, that can actually help in the favor of the project. Now, another important factor to consider is the unit positioning. Now, the corner units are actually the worst performing ones usually because of, again, their exposure to the environment. But the mid floors, which are stacked in between the levels, are usually performing the best. And of course, there's a whole range of additional consideration we look at, such as the glazing ratios, the facade design choices, and even how the stack effect influences the project. All of these variables shape how we optimize the building type.
So when you're optimizing an apartment project, what's your typical approach?
Our starting point is always to identify thermally unique apartment designs. We model those and test them across different exposure levels and different orientations to understand which apartments are performing naturally better and which ones are the worst. Once we know the performance ranges, we start exploring the most cost-effective improvements. That could mean recommending small design changes, swapping with more efficient materials, selecting smarter glazing options, tweaking surface colors, or refining insulation levels, whatever delivers the best outcome. And really, the goal is not just to hit the number. It's about achieving the required performance in a way that's efficient, practical, and commercially sensible. We aim for solutions that work for the building, the budget, and ultimately the people who are actually occupying the space.
how does Suho's optimisation service align with Australia's 2050 net zero goal?
That's a really good question, actually. When optimizing the buildings, we look beyond minimum standards. We integrate thermal comfort targets, renewable energy potentials, reduce grid dependency, and the air tightness performances. Those early decisions can actually move the projects several steps closer to the net zero target before the construction even begins.
Love that. Now, what are the biggest wins for architects, developers, and the people who will eventually live in the buildings?
I would actually like to summarize this in 3 key different points. The first one could be the cost saving and future proofing. By modeling options early, we avoid the last minute design changes or compliance surprises. We give teams a clear data-driven choices so that they can pick upgrades and the building specifications and deliver maximum impact without blowing their budget. Second point could be better indoor environments. So you improve the quality. So we're just not adding insulation. We're optimizing for comfort, such as daylight, airflow, stable temperatures, reduced mechanical heating and cooling. That leads to healthier and more resilient buildings for longer lifespan. Third point could be data-driven thermal comfort. We calculate how many hours spaces are naturally comfortable, demonstrate how different upgrades shift that performance. It means actually smarter design and design decisions and fewer weak spots in the design.
So you're not just ticking boxes, you're helping teams build smarter.
Exactly. Optimization not only covers compliance, but it also boosts livability. It protects the long-term investments and prepares the project for stricter future regulations and changing climate.
Thanks, Sumit. That was great. So if you're designing apartments and want fewer headaches, better insights and stronger, more sustainable performance, chat with our team about optimizing your Class 2 design. Drop us a message or head to our website to learn more.